Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video we're going to be looking at solving trig equations. So by the end of this lesson, you'll be able to solve simple trig equations, solve them with compound angles, solve equations with more than one trig function, and solve trig equations that reduce to quadratic equations. Now, solving trig equations involves finding the angles that will result in the trig ratio in a given domain. When we enter our working into the calculator, it only gives you one answer. This is known as the principal solution. Now, I like to refer to this as the reference angle. However, we need to use that answer to solve the actual problem. So this is the quadrants and related angle method that we use. What we need to do is we need to draw a quadrant diagram, then draw a ray in each quadrant that the angle could be in, depending whether it's a positive or negative answer. Find the related acute angle, or the reference angle, by using your calculator. Never enter a negative number into the calculator to find the related acute angle. Mark the reference angle between the rays drawn and the x-axis. Okay, only the x-axis, not the y-axis. And then solve the equation. So let's have a look at the first one. Solve simple equations. Here we've got solve cosine x is equal to root 3 over 2 in the domain from 0 to 360 degrees. Sometimes the question might ask you for the answer in radians, and if it does, it'll give you this domain instead. 0 is less than or equal to x, which is less than or equal to 2 pi. So if you see pi, we know to give our answer in radians. So throughout this entire video, I'm going to give both answers. One set in degrees, and then I'll just convert it to radians, because I find that particularly a lot easier to do than to just work with radians throughout. So I like to work in degrees, and then if the question needs me to give the answer in radians, I just convert it then. So what we need to do here is we can see that cosine of x is equal to positive root 3 on 2. Okay, it's not a negative root 3 on 2, it's positive. So when I draw my quadrants, all stations to central, where is cosine positive? It's positive here and here in those two quadrants. Now that I've done that, I know that I actually need to work out the reference angle, so I know how big that angle is and how big this angle is between the ray and the x-axis. Do not ever do it here or here. So x is equal to the inverse cos of root 3 on 2. Let's put that in our calculator. Inverse cos of root 3 over 2 is 30 degrees. So that means we know that this is 30 degrees and that this is 30 degrees. Okay, now we want to work out the answer in this domain from 0 to 360 degrees. So we've got the 30 degrees, which is this bit here. But we also need to work out this angle here. That is what x is equal to as well. So technically that's 360 minus the 30, which is 330 degrees. And that's my answer. Okay, we can just double check to make sure that both our answers are within the given domain between 0 and 360. Now, if the question said in this domain, then I'll now convert it into radians. So I'll just do all of that in blue. We take our angle, divide it by 180. So that's 1 pi on 6. Pi on 6. Or the next one, 330 over 180 is 11 pi on 6. Okay, so if the question wanted you to put it in radians, that's my answer. Otherwise, I would just leave it in that if the question asks for it in degrees. Okay, let's have a look at question B. 2 sine squared x minus 1 is equal to 0. So first thing I need to do is I need to get sine x by itself. So if I have 2 sine squared x is equal to 1, move the 1 across. Divide both sides by 2. Now it's important for you to know that sine squared x is actually the same as sine x squared. We just write it like this so we don't have to write brackets. So what we're going to do is we're going to square root both sides. So sine x is equal to plus minus the square root of half. So when we draw our quadrants, all stations to central, where is sine positive? Here and here. Where is sine negative? Here and here. So we actually need all four. Okay. So I'm going to say x is equal to the inverse sine of the square root of half. So find my reference angle. So inverse sine of the square root of half is 45 degrees. So I know that's 45, I know that's 45. This one and this one are all both 45. Remember, always between the ray and the x-axis, the horizontal. Okay, so now we know that it's 45. Let's work out the rest of them. So we've got 45 for this one. We've got 180 minus 45, that's 135 for the next one. We've got 180 plus 45, which is 225 degrees for the next. And for the last one, let's do that here. Technically, that's 360 minus 45, which is 315 degrees. Okay, and that's it. If we want to convert it into radians, just divide everything by 180 and put pi at the top. So 45 over 180 is pi over 4. Do it in blue. 135 divided by 180, 3 pi on 4. And we could do the same with the others. This will be 5 pi on 4 and 7 pi on 4. Okay, so that's if that was the domain. Okay, question C. Tangent of x is equal to root 3. So the first thing I would do, all stations to central. Where is tan positive? Here and here. Okay, let's look for our reference angle. So our reference angle, x is equal to the inverse tan of root 3. $60. So I know that's 60, and I know this is 60 degrees. So technically it's 60 and 180 plus 60 is 240 degrees. However, our domain's from negative 180 to 180. That one fits, but this one doesn't. So what we want to do is, we want to take this number and we need to minus 360 degrees. 1 full revolution, because if we were to go backwards 360 degrees, we'll go back to its exact same spot. So 240 minus 360 is negative 120. And that's exactly the same. And now we've got the two angles that are in the given domain. Again, if the question wanted us to answer in radians, it will have given us this, negative pi to pi. Remember pi being 180 degrees. So we just do the same thing, divide by 180. That's pi on 3, and that's going to be negative 2 pi on 3. Okay. Question D. Cosecant x is equal to negative 2. Now that tells us, the third letter, that is 1 over sine x. 1 over sine x is equal to negative 2, or negative 2 over 1 if you want. So what I'm going to do is I'm going to flip both sides. Sine x is equal to negative half instead. Now I will draw my all stations to central. Where is sine negative? In the third and fourth quadrants. So instead of writing x is equal to the inverse sine of half, right? Because we want, like I said in the instructions before, we never put a negative in here, just put a positive to find the reference angle. But because we're getting x, or the reference angle is this bit here, I don't want that. I'm not going to call it x, I'm just going to call it something else. I'll call it alpha. Alpha for the reference angle. So we're going to do inverse sine of half is 30 degrees. So I know the reference angle is 30 degrees, so this is going to be 30 here, and this is going to be 30 over here. So what is x actually equal to? Well, x is equal to 180 plus 30, 210 degrees, and technically 360 minus the 30, which is 330 degrees. However, we notice that both of them lie outside the given domain. The given domain is from negative 180 to 180. So what we actually need to do is we need to minus 360 from both of them. So if I were to do 210 and minus 360, one full revolution, we get negative 150 degrees. And we take the 330 and subtract 360, we get negative 30 degrees. And now we can see that both of them lie in the given domain. Okay, let's convert that to radians if the question asks us to. So 150 on 180 is 5 over 6, so we've got negative 5 pi over 6. And we've got 30 over 180, so that's negative pi on 6. Okay. Question E. Secant x is equal to 1.2. Well, that tells us it's 1 over cos. 1 over cos x is equal to 1.2 over 1. We can flip it. Cosine of x is equal to 1 over 1.2. So we can see here that cosine is positive, all stations to central. Cosine is positive here and here. Okay, let's now find a reference angle. So x is equal to the inverse cos of 1 over 1.2. Probably do this to 2 decimal places. (33.56 degrees). So that means this angle here is 33.56 and this angle here is 33.56. Alright, now that we've done that, we've got that one, we still need to work out this angle, which is technically 360 minus that, 326.44. Okay, now the question here gives us this domain between negative 180 and 180. That one's good, but this one isn't. So what we need to do is we need to take that answer and minus 360 from it to get negative 33.56. And now that's in that answer. Now if we want to convert this to radians, we can. 33.56, oops, 33.56 divided by 180. Which is 839 pi over 4,500. Okay, and the other one will just be the negative version of that. Okay, let's have a look at compound angles. Now, compound angles is when our angle is not just x by itself. We've got something else with that x. So what's going to happen is it's going to change our domain. So our domain is currently 0 degrees is less than or equal to x, which is less than or equal to 360. Well, we actually need to change it by replacing x with whatever's the angle, 2x. Okay, now how does this x become 2x? We need to times it by 2. So we're going to do exactly the same thing for both of these ends. 0 times 2 is still 0. 360 times 2 is 720 degrees. So now we have a new domain. We are going to use that to work out all the possible angles in that new domain, and then we will make sure that our final answer is within the given domain. So we've got tan of 2x is equal to root 3. So I'm going to draw up my quadrants, all stations to central. Where is tan positive? Because this is positive, here and here. And now we need to find our reference angle. So 2x is equal to the inverse tan of root 3. Let's put that in our calculator. That's 60 degrees. So I know that's 60 degrees, and I know this is 60 degrees. So it's not just 60, it's also 180 plus 60, which is 240 degrees. But we can actually keep going because our new domain is all the way up to 720. So if I were to keep going, 360 plus another 60 to get back to this line, that's 420 degrees. Or 360 plus another 180 plus this 60 to get to this line. That's 240 plus 360, that's 600 degrees. Now, of course, this looks ridiculous, so I prefer not to do all of that. What I would like you to do instead is, once you've done from 0 to 360, just add 360 degrees to both sides. No, to both angles. Okay, so 60 plus 360 gives us 420. 240 plus 360 gives us 600. And these are the four angles that will be between 0 and 720. Now that we've done that, we can actually divide every angle by 2 to get x by itself, because it says 2x is equal to. So we want what x is equal to. X is therefore equal to 30 degrees, 120, 210, and 300 degrees. And we can see that all four of these angles are within the given domain between 0 and 360. Of course, if the question asks us to put in radians, we can convert them to radians, divide them all by 180. So that's pi on 6. 120 on 180 is 2 pi on 3. 210 on 180 is 7 pi on 6. And 300 on 180 is 5 pi on 3. Okay. Let's have a look at question B. here we have 2 sine 2x minus 1 is equal to 0. So I'm going to, I want sine 2x by itself. So we've got 2 sine 2x is equal to 1. Sine of 2x is equal to half. So it's a positive half. All stations to central. Sine is positive here and here. And now I can work out my reference angle. However, I need to have a look at this. And I notice that this is a compound angle, so it's going to change my domain. So my domain is going to be from, so we got 2x here. Going to times everything by 2. So 0 times 2 is 0. 360 times 2 is 720. Here's my new domain. So the angle 2x is equal to the inverse sine of half. Let's put that in our calculators. 30 degrees. So I know that that's 30. And I know that that's 30. So it's not just 30 degrees, it's 180 minus 30, 150 degrees. But because of our domain goes all the way out to 720, I'm just going to add 360 to both of them. So 30 plus 360 is 390. 150 plus 360 is 510. Alright, and now we can work out what x is equal to, because 2x is equal to all of these. So we're just going to divide all of them by 2. 15 degrees, 75, 195, and 255 degrees. Okay, if we want to convert it to radians, divide them all by 180. Pi over 12. This will be 5 pi over 12. 195 over 180. 13 pi over 12. And 255 on 180. 17 pi over 12. Okay, and so we can see that our answer, the one in degrees, is in the given domain from 0 to 360. Alright. Sine of x minus 250 is equal to root 3 on 2. So I know it's a compound angle, so I'm just going to write this in what my new domain is. Well, how do I go from x to x minus 250? I need to subtract 250 from each of these. So 0 minus 250 is negative 250. 360 minus 250 is 110. Okay, minus 250 from all of them. And that's my new domain, from negative 250 to 110. So because sine of this angle is positive, all stations to central, where sine positive, here and here. Let's work out our reference angle. So x minus 250 is equal to the inverse sine of root 3 on 2. Oops. $60. So I know that's 60 and I know that's 60. So it's not just 60, it's 180 minus 60, which is 120 degrees. However, we notice that this one is in the domain, but this one isn't. This one's outside of the 110. So what we need to do is we need to minus 360 from it. So 120 minus 360, it should be negative 240. and now that's within the given domain. Once we've done that, now we can add 200, because this is technically x minus 250 is equal to that. So now we can work out what x is equal to. 60 plus 250 is 310 degrees. Negative 240 plus 250, that's 10 degrees. And now we can see that our answer is in the given domain. Let's convert that to radians. 310 over 180. 31 pi on 18. And 10 on 180. Oops. 1 pi on 18. Pi on 18. Okay. Part 3, equations with more than one trig function. Solve sine x plus root 3 cos x is equal to 3. Is equal to 0, where the domain is from 0 to 360, or from 0 to 2 pi. So what we need to do here is we can't have two different trig functions. We can only solve it when there's only one trig function. So what I'm going to do is I'm going to move this to the other side. So we'll have sine x is equal to negative root 3 cosine x. Then I'm going to divide both sides by cosine x. If I divide both sides by cosine x, this will cancel, and now the sine x on cosine x is equal to tan x. And now I finally have just one trig function. What I'm going to do is I'm going to do my quadrants, all stations to central. Where is tan negative? It's negative in this quadrant and in this quadrant. Okay, so let's work out what the reference angle is. Now, because it's negative, in my calculator, I'm not going to put a negative. So I'm going to work out alpha instead of x, just to work out what the reference angle is. Inverse tan of positive root 3. $60 degrees. So I know that's 60 and that's 60, always between the ray and the x-axis. So the reference angle is equal to 60. So what is x equal to? X is equal to 180 minus 60, 120 degrees. And 300 minus 60, 300 degrees. Okay, and we can see here that answer is in our given domain. Let's convert this to radians. That's 2 pi on 3, and 300 on 180 is 5 pi on 3. Of course, you can always double check your answers, right? So here's my calculator. If I were to have sine of 120 plus root 3 cosine of 120, yep, I get 0. And we can do the same thing with 300. Yep, I get 0. Okay, which is what the question actually says. It will equal to 0. So you know you did it correctly. Okay, last part of this video. Trigonometric equations that reduce to quadratic equations. So here we've got solve 2 sine squared x plus sine x minus 1 is equal to 0. What you need to see here is that this is sine squared, this is just a normal sine, right? So what we need to do is we need to use substitution. We need to let u equal to sine x, and we are going to rewrite this question as technically 2u squared plus u minus 1 is equal to 0. Now we've got a quadratic equation. This is a non-monic, so we need to factorize this. So I'm just going to factorize this. 2 times minus 1 is minus 2. And then two numbers that multiply to negative 2 but add to positive 1 are 2 and minus 1. So we've got 2u plus 2 times 2u minus 1 all over 2. Okay, so that's where this 2 goes. Minus 1 goes there. And that will factorize to u plus 1 2u minus 1, because when the 2 comes out for this, the 2's will cancel, leaving me with u plus 1. So we've got u plus 1, 2u minus 1 is equal to 0. Therefore, u has to equal to negative 1, or u has to equal to positive half. Now we said previously that u is sine x. So sine x is equal to negative 1, and sine x is equal to positive half. These are the two equations that we need to solve. Whereas sine negative here and here, and where is sine positive here and here. Okay, so let's have a look at the first one. Sine x is equal to negative 1. So let's find a reference angle. Inverse sine of 1, oops, of 1 is 90 degrees. So that means the angle formed from the x-axis to the ray should be 90 degrees. So technically it should be all the way over here, 90 degrees. And from this one, from the x-axis all the way to the ray, that should also be 90 degrees. So there's only one real answer. X therefore has to equal to 270 degrees. And for this one here, we have x is equal to the inverse sine of half. Which is 30 degrees. So that's 30 and that's 30. So that's 30 degrees and 150 degrees. So my final answer is x is equal to 30 degrees, 150 degrees, and 270 degrees. And we can see that that's it. Now, we can always check that. Here's my trusty calculator. So remember, sine squared x means sine x squared, like all squared. So if we were to do 2 sine of 30, oh, let's do this again, 2, and then we want to square sine 30 plus sine of 30 minus 1. Yep, it gives us 0, so we know that's correct. We can check it with 150 as well. Yeah, that's equal to 0. And 270 is going to give us 0 as well. Okay, and that's it for that one. If you want to put it in radians, you can. I won't do that here. Alright, and last one, we've got 2 cosine squared x plus 3 sine x minus 3 is equal to 0. Here we see that we've got a squared. We don't have a squared here, and they're both different. We've got cosine and sine. So what I'm going to do is I'm going to remember my trig identity, that sine squared x plus cos squared x is equal to 1. So that means cos squared x is technically equal to 1 minus sine squared x. So I'm going to substitute that into where it says cos squared x. So technically I've got two lots of 1 minus sine squared x plus 3 sine x minus 3 is equal to 0. And now they're all in terms of sine. What I'm going to do is I'm going to expand these brackets. I am going to simplify this, collect like terms. 2 minus 3 is -1. And because sine squared is negative, I'm just going to move everything to the right hand side, make it positive. So there'll be nothing left on the left hand side. We'll have 2 sine squared x minus 3 sine x plus 1. And now I'm going to use substitution. Now I'm going to let u equal to sine x. That means I'm going to rewrite this as 0 is equal to 2u squared minus 3u plus 1. Again, this is a quadratic equation that we can factorize and solve. So this is non-monic. 2 times 1 is 2. The two numbers that multiply to 2 but add to -3 are minus 2 and minus 1. So 2u minus 2, 2u minus 1 all over 2. That will factorize to u minus 1, 2u minus 1. So 0 is equal to u minus 1, 2u minus 1. So u has to equal to 1, or u has to equal to positive half. If u is sine x, we're technically doing sine x is equal to 1, and sine x is equal to half. Whereas sine positive here and here, whereas sine positive here and here. Okay. So x is equal to the inverse sine of 1. That's going to give us 90 degrees. So technically, it's going to push this over here, and it's going to push this one in the same place. It's just 90 degrees. When sine x is equal to half, x is equal to the inverse sine of half, which should be 30 degrees. Let's just double check that. Inverse sine of half, yeah, 30 degrees. So I know that's 30, I know that's 30. So it's not just 30, it's 30 and 150 degrees. Therefore, x is equal to 30 degrees, 90 degrees, and 150 degrees. And that's it. Again, you can check your answers by substituting these values into the original equation and seeing if it equals to 0. But yeah, that's solving trig equations. Thanks.